Hello everyone to the last section in Chapter 5. This is 5.6, Integration by Substitution. One of the most important concepts you're going to see. Okay? The key concept for today here is this is u-substitution is the chain rule for integration. So if we have an outside and an inside function, we have to do u-substitution. How do we do this? Quick run through. We determine the inside and call that u. We calculate du and see if it's already in the problem. If it's there, great. If it's missing, we must multiply to include it. If we multiply on the inside, we must balance on the outside by multiplying by the reciprocal. We integrate the inside with u and we change the u back into an x. A better way to think about it, since we're changing from x to u, we need to have a du in the problem to unlock the problem. Every integral we have has a dx, so now it needs a du. If we don't have it, can we include it by multiplying? If so, how can we balance the problem? Remember, we can never include a variable when we're trying to balance. If we include a variable, we have to completely rewrite the problem, which is not fun. Here's why. Let's say that you're going to multiply by an x inside the problem. How do you balance out multiply by x? Well, you multiply by 1 over x. What's wrong with this? X can be any number. What if x was 0? Then not only have you multiplied by 0, but you're dividing by 0. And that completely messes everything up. Okay, let's dive into this. What function is inside something? X squared plus 1 is inside a squared, so we're going to call that u. Then what's du? Well, what's the derivative of x squared? It's 2x, and I'm going to put the dx there. So let's look at this problem. This is u squared, and this is du. So let's rewrite the problem. This is the integral of u squared du. That's an easy integral to do. What is the integral of u squared du? It's 1/3. Hold on. It's 1/3 u cubed plus c. Never leave an answer like that, though. What was u? U was x squared plus 1 cubed plus c. And there's my answer. Quick run through. Whatever's inside we call u. We calculate du. If it's there, great. So now I wrote the problem with u's. I integrated because there's no more outside and inside. I changed the u back to x's. I did not have to balance because it was already there. Let's take a look at this problem. People have trouble with this one. Because what's inside of something? Well, a lot of people would say that secant is inside of something. It's inside squared. That makes du, what's the derivative of secant? It's secant x tangent x. We don't have a secant x tangent x. We have a secant divided by tangent, but it's not the same thing. So this is not the correct way to do this problem. We can't call secant u. We're going to call tangent u. Why is tangent inside something? What is tangent inside of? Tangent's inside of a negative 1 power. Then what's that make du? What's the derivative of tangent? Secant squared. Hey look, we have secant squared. So this is going to become, this part right here is going to become du, and this right here is going to become 1 over u. Now, it's a lot easier to integrate. What's the integral of 1 over something? And people always forget this. The integral of 1 over something is natural log. Don't ever leave the u's in there. Change it back. What is u? U is tangent of x. I have to include absolute value because tangent can be positive or negative, but I can only take the natural log of a positive number. So far, it's been pretty easy. Identify u. Sometimes you have to try both of them. Calculate du. Hope that it's already in the problem. rewrite the problem, integrate, change the u. But what happens if we're missing something? For example, in this problem, the u is 6x plus 1, which makes the du 6 dx. I need a 6 right here. That's legal, as long as I multiply by a 1/6 out here. I've now balanced the problem. So this problem is really 1/6 the integral of u to the 4th du. That makes it 1/6 1/5 u to the 5th plus c. And it makes your final answer 1/30 6x plus 1 to the 5th plus c. Quick recap here. Call the inside u. Calculate du. Did I have it? No, I didn't. Can I make it? Yeah, by multiplying 6 there. Balance with the 1/6 outside. Rewrite your problem with u's. Integrate, and don't forget the 1/6 out front. Change the u's back into x's. So if we're missing a constant, we can multiply it in there as long as we balance it out on the outside. Let's take a look at this one. People struggle with this until I rewrite it. That is 2x plus 5 to the negative 1/2 dx. What's u? 2x plus 5. What's du? 2 dx. Do I have du? No. Can I make du? Yep. As long as I put a 2 here, then I have du. Balance it out with a 1/2 out front. So now I have 1/2 the integral of u to the negative 1/2 du. That is 1/2 times, if you add 1, you get u to the positive 1/2. Flip it, put it in front, you get a 2 plus c. Multiply in and turn back, you get the 2 and the 1/2 cancel, so I get u to the 1/2, which is 2x plus 5 to the 1/2 plus c. Or if you wanted to, you could write that as square root of 2x plus 5 plus c. Either answer is fine. Just make sure you convert it back. Quick review. Found u, calculated du, had to include a 2, so I balanced it with a 1/2, rewrote it, integrated it, plugged in the x back in. How about a problem like this? What's inside of something? X squared plus 2x is inside of something. It's inside of a negative 1. Du is 2x plus 2 dx. Do I have a 2x plus 2 dx? No, I have a 1x plus 1 dx. So what can I multiply everything by? 2. Balance it, I get a 1/2. So now my problem is 1/2. This all becomes du, and that becomes 1 over u. What's the integral of 1 over u? It's natural log, absolute value of u. What's u in this problem? It's the natural log of the absolute value of x squared plus 2x plus c. Lots of practice problems, and you'll see there's a mini lesson on YouTube about this, so make sure to check it out if you're having trouble. Very similar problem. Call u 3x plus 2. That means du is 3 dx. I need a 3, so I need a 1/3. So that's 1/3 integral of 1 over u du. That's 1/3 the natural log of the absolute value of u plus c, which is 1/3 the natural log of the absolute value of 3x plus 2 plus c. try to do it like this, call u x squared plus 1, du is 2x. I have an x squared plus x plus 1, and I need just a 2x. I can't do that. So what do you think I'm going to do? What does that line, that bar, mean to do? That bar means to divide. So I've got to divide this problem out. X squared plus 0x plus 1 divided by x squared plus x plus 1. Okay? Nope, I wrote it backwards, didn't I? X squared plus x plus 1 over x squared plus 0x plus 1. Nope, I was right the first time. X squared plus 0x plus 1, x squared plus x plus 1. Top goes on the inside, bottom goes on the outside. So, how many times will x squared go into x squared? 1 time. That gives me x squared plus 0x plus 1. If I subtract, I get x, and that's it. So my remainder is x, so I have an x over an x squared plus 1. So now my problem is the integral of 1 plus x over x squared plus 1 dx. Let's split that into two problems. It's the integral of 1 dx plus the integral of x over x squared plus 1 dx. Why did I split it? Because this is easy. This is just x plus. But to do this problem, I have to do u-substitution. U is equal to x squared plus 1. Which makes du 2x. So I need a 2 right there, a 1/2 right there. That's the integral of 1/2, 1 over u du. Which makes this whole thing x plus 1/2 natural log of the absolute value of u plus c, which is x plus 1/2 the natural log of the absolute value of x squared plus 1 plus c. Watch this. This has to be positive. Is x squared positive? It always is. If I add 1 to it, is it still positive? Sure is. So in this problem, I don't need the absolute value bars, because x squared plus 1 will always be positive. Again, check out the mini lesson on YouTube if you're having trouble with this. Uh-oh. Extra placement. Let's just do what we normally would do. If you call u 2x minus 1, that makes du 2. I can put a 2 in. Sorry, there needs to be a dx to this problem. I can put a 2 in and a 1/2 out here. But what is still in the problem that's we can't get rid of? I have an x here. I can't cancel it out by putting a 1 over x there, because 1 over x might not exist. So if u is 2x minus 1, then u plus 1 equals 2x. So x equals 1/2 u plus 1/2. Now why is that important? Because I can now rewrite the problem like this. 1/2. The 2 dx becomes du. This becomes u to the 1/2 power. And what is the x going to become? X becomes 1/2 u plus 1/2. So what did I do? I did my normal process, but I had to replace the x with what it was equal to in u's. Let's multiply in. 1/2 u times u to the 1/2 is 1/2 u to the 3/2 plus 1/2 u to the 1/2 du. Now let's integrate. This is 1/2. 5/2. Put a 2/5 out front. 1/2 times 2/5 is 1/5. Plus, that's going to be u to the 3/2. 2/3 times 1/2 is 1/3. Plus c. For your final answer, I'm going to distribute in and convert back. That's 1/10. U is 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. An x replacement is what the majority of the mini lesson online covers. X replacement is what the mini lesson mostly covers. Okay? Last thing. Definite integrals. What if there are bounds? If there are bounds, we have to change the bounds. If the bounds are x's, when we do u-substitution, we can either change the u's back to x's, or change the bounds from x's to u's. What do I mean by that? Well, let's just take a look at an easy problem. I have a definite integral of x times x squared plus 1 cubed. So let's call u x squared plus 1. That makes du 2x dx. Hey, I just need a 2 and a 1/2. So, I have 1/2 the integral of u cubed du. I can't put 0 and 1 here because 0 and 1 were x values. So I've got to change the x values of 0 and 1 to the u values. We'll plug in 0. If you plug in 0 right here for x, what do you get for 1? Or for u? You get 1. If you plug 1 in here for x, what do you get for u? 2. That's what I mean by changing the bounds. From the x values of 0 and 1 to the u values of 1 and 2. The advantage is now I don't have to go back to x's. Help me integrate. That's 1/2. That's 1/4 u to the 4th, evaluated from 1 to 2. I don't have to change it back to x's. That is 1/2 times, put 2 in there, you get 2, 4, 8, 16. 1/4 of 16 is 4, minus, put 1 in there, you get 1/4. That's 1/2 times 15/4, which is 15/8. I changed the bounds from 0 and 1 to 1 and 2 because I'm dealing with u's. And that's it for u-substitution and all of Chapter 5. As always, guys, check the extra work on Edline. Come to class, ask me questions. I'm here before and after school. Check the mini lessons on YouTube. Okay? If you have any questions, come talk to me. Thanks, everyone.